Right now, 15 billion miles away from the Sun, a machine built in the 1970s is slowly freezing to death in deep space. Out here, there are no mechanics, no spare parts, and definitely no gas stations. Before we go further, name just one of the planets Voyager visited in the comments below. The spacecraft runs on radioisotope thermoelectric generators, or RTGs. These nuclear batteries rely on decaying plutonium. Physics dictates that every single year, they produce fewer and fewer watts of electricity. Look at this trajectory map showing the path out beyond the termination shock. Voyager 1 is now deep in the interstellar medium, roughly 166 astronomical units from Earth. At that distance, a single radio transmission takes nearly 23 hours to cross the void. Because of that 46-hour round trip for a single communication, real-time remote control is physically impossible. The spacecraft operates entirely at the mercy of pre-programmed survival commands and agonizingly slow physics. The decay of plutonium dictates an inescapable timeline. Every day, the internal wattage drops closer to the minimum required to keep the processors running. This raises a practical engineering question. What exactly happens to a highly complex machine in the interstellar medium when it drops to zero? Beyond the inevitable loss of signal, the probe's trajectory ensures a passive phase to its journey. Right now, we are actively witnessing the agonizingly slow, inevitable flatline of humanity's farthest physical extension into the universe. To stretch the remaining power supply, Mission Control has been performing active deep space triage. Over the past few years, they've systematically shut down non-essential heaters and powered off science instruments. The engineers have executed complex workarounds, like reviving long-dormant thrusters from billions of miles away, carefully uploading new code that trickles into the computer at mere bits per second. Quick trivia break. Does sound actually travel in space? And do you know the exact year Voyager 1 launched? Drop your answers in the comments. Right now, the team is literally trading the spacecraft's internal heat and active science data just to buy a few more days of a heartbeat. By the early to mid-2030s, the decaying plutonium will reach a critical threshold. The RTGs will simply fail to produce enough electricity to run the central systems. There is no dramatic shutdown command sent from Earth, and no self-destruct sequence. The probe will simply lose the physical strength needed to power its transmitter. Here on Earth, the massive 3.7-meter receiving dishes of the Deep Space Network will listen to the coordinates, and they will hear absolutely nothing. The connection will be permanently severed. Since we're tracking long-distance signals today, let us know what city you're watching this video from right now, so we can map our own signal reach. The moment that antenna goes silent, Voyager's active science mission is over. It officially becomes an unpowered piece of space debris. Without the friction of an atmosphere to slow it down, the frozen physical object will never stop moving forward, cruising at several kilometers per second. Space is so unfathomably empty that Voyager 1 will drift through the Milky Way for millions of years as a ghost ship. It is highly unlikely to ever collide with a single star or planet. The end of its active science mission is exactly what triggers its billion-year backup plan. Bolted directly to the side of the spacecraft is a gold anodized aluminum record. Technically, it's not made of solid gold. Do you know what metal forms its core? And do you believe an alien civilization will actually ever find it? The spacecraft will spend the next billion years as a silent, physical record of the species that built it. To communicate with a finder that shares no common language, the record must explain its own operation through the laws of physics alone. The cover diagram illustrates a hydrogen atom's hyperfine transition. Its electron flips spin predictably, acting as a 1420 MHz cosmic clock. This frequency provides a physical instruction. Spin the record 3.6 seconds per rotation. Scanning the stereo waveforms every 8 milliseconds decodes hidden images of Earth. Embedded in that math are greetings in 55 languages, the intricate melodies of Bach, and the driving rhythm of Chuck Berry. The engineers who launched this probe knew the plutonium would eventually run out. They built this disk to carry the memory of our existence into eternity. Voyager 1 carries the specific sounds and images of Earth into a future where the people who made them are long gone. If you want to explore more of the universe's greatest mysteries, hit subscribe and share this video to uncover the next secret.